Hi everyone, welcome back to another video on Oxbridge and Imperial Science and Engineering majors interview study session. Today we're going to look at a frightening maths problem. So we're going to solve this integral. I haven't seen this problem before and I hope you haven't seen it either. So we can go through the steps clearly, step by step, so you know exactly how to present your ideas clearly to the interviewer during the interview. So let's get started on this problem. So the question is very clear. It asks you to solve this indefinite integral. We're given this whole chunk of integral, and it seems very frightening indeed. Now what we got to do is think about some techniques of solving integrals. So notice that in the denominator, the polynomial is to the power 5, and on the numerator, the polynomial is to the power 4. What this means is we can think about using substitution, but then something would jump at you and say, well, this doesn't make sense because you can't use substitution on this. Because if it's substitution, then the numerator would start with 5x to the power 4, which is not the case. Then another way of solving this problem could be using perhaps partial fractions, and that might work. Let's get started. So let's think about x to the power 5 minus 3x to the power 4 plus 3x cubed and minus 5x squared plus 12. Can I find factors? Well, let's test out some values. 0, it doesn't work. 1, it doesn't work. Minus 1, what about minus 1? Well, x equals minus 1. This would be minus 1 minus 3 minus 3 minus 5 plus 12. This is 6, this is 7, and this is 12, minus 12. So x plus 1 is minus 1 is a factor. So we can say, well, this is equal to x plus 1 times the following. Now let's apply synthetic division. So to the polynomial 1 minus 3 plus 3 minus 5, 0 and 12. Applying synthetic division, we have minus 4, 4, 7, minus 7, minus 12, 12, 12, minus 12, 0. So it's x plus 1 times. So that means the denominator can be factorized as x plus 1 times x to the power 4 minus 4x cubed plus 7x squared minus 12x plus 12. So this is sort of what we have here. Now let's think about what else we can do to the expression. Can we factorize it this further? We've tried 0 and plus and minus 1. Let's try 2. So when x equals 2, 2 to the power of 4 is 8, minus 2 to the power of 3 is 8, 4 times 8, 32, plus 4 times 7, which is 28, minus 24 plus 12. This becomes, let me see, so that is 4, that is 24 minus 32 is not equal to 0. So let's try when x equals minus 2. Well, if it's minus 2, then it's 8 plus 32 plus 28 plus and it wouldn't work. So what about when x is equal to, let's say half or something? Would half Makes sense. I don't think x equaling a half would be a factor because you have x to the power 4, which means that in one of the terms you'd get an eighth, and getting an eighth would mean that there's no factorization going on. So let's try x is equal to 3, then you get 3 to the power 4, which is 81 minus 3 to the power of 327 times 4, which is equal to, let's see, 27 times 4, so that's 8, so 108, plus 7 times 9, which is 63, minus 36, plus 12, and this becomes, so 63 minus 36, that is 27, 27 plus 12, that is 39, so 120, x cannot be equal to 2, cannot be equal to minus 2, blah blah blah. Okay, so we don't know if this will be factorized or not. So let's rewrite the integral down here. What we have is, what we're asked to do is find the definite integral of, let me see. So the integral, the numerator of the integral is 3x to the power 4 minus 7x cubed plus 9x squared minus 8x plus 9 divided by x plus 1 times, let me actually check if the one of the factors is indeed correct. Minus 4 plus 7 minus 12, 12. Okay, so it should be x to the power of 4 minus 4x cubed plus 7 squared, x squared, and minus 12x plus 12. So minus 12x plus 12 dx. Remember the dx. So, okay, let's think about if we can simplify the numerator a bit. So 3x to the power 4. Okay, let's think about, okay, so does let's analyze numerator. When x is equal to 1, what you get is 3 minus 7 plus 9 minus 8 plus 9, and obviously it's not equal to 0. When x is equal to minus 1, you get 3 plus 7 minus 9 plus 8 plus 9. That is not equal to 0. Okay, so there's no simplifications here. So let's proceed with partial fractions. It's gonna be a partial fractions problem. So it's x plus 1 is the denominator, and of the second partial fraction, it's x to the power 4 minus 4x cubed plus 7x squared minus 12x plus 12. Let's solve this partial fraction. We get a times blah blah blah. Let's just highlight the whole thing. A times that plus b times x plus 1 is equal to 3x to the power 4 minus 7x cubed plus 9x squared minus 8x plus 9. So looking at this expression, we can immediately deduce that x is equal to 3 because if you think when you look at the denominator, you'd see that on the left hand side, the highest x to the power of, on the left hand side, the x to the power of 4 has a coefficient of a, and on the right hand side it's 3, so therefore they must be equal. So a is equal to 3, and we know that 12a plus b must be equal to 9. We know that a is equal to 3, so b is equal to 9 minus 36, which is equal to minus 27. Yeah. So b is equal to minus 27. So now we are essentially solving the integral of 3 divided by x plus 1 plus x to the power 4 minus 4x cubed plus 7x squared minus 12x plus 12, and it is minus 27 on top here. First of all, I have to verify if that is the correct expression. So let's take x cubed, for example. Oh, this is incorrect. This thing is incorrect. Because if you take x cubed, on the left hand side, the value is minus 12x cubed, whereas on the right hand side it's minus 7x cubed. So they are definitely not equal to each other. So, okay, that's not equal to each other. So let's think about something else. Okay, let's rub things out. Okay, so let's think about this expression for a second. Okay, so we can't do a partial fraction like this. It's unsolvable, right? So let's think about how we can simplify x to the power 4 minus 4x cubed plus 7x squared minus 12x plus 12. How we can simplify that even further. And thinking about the things we've tried out, 2 minus 2, 3. What about minus 3? I know it's going to be positive. What about 4? Would 4 work? So x equal to 4, we get 4 to the power 4 minus 4 to the power 4, so it cancels out. 7 times 4 squared, 16, which is 112 minus 48 plus 12. Can't be 4. So here the problem is we can't actually find a factor here, and we can't find a factor. If we can't find a factor, then what happens is we won't be able to solve this integral, because we know that minus 1 is a factor, and plugging in minus 1 we're able to simplify down the equation. 7 minus 12, 12. Yeah. Okay. So we're able to get down to x to the power 4. That's all we can do at the moment. How could we solve this partial fraction? Let's just think about for a second. How are we able to solve it? Well, let's think about, is there a way here about it? There doesn't seem to be a way. Anything that resembles to be a way of solving this problem. Well, let's have a look at some hints that were provided. So it says factors of polynomials. We need to take account of that, which we did. Long division, we did that. Simple partial fractions. Partial fractions with repeated factors. One of the things to consider is partial fractions with repeated factors. And in this case, there would be repeated factors. Because it's on the hints. How can we get partial fractions with repeated factors? Well, there must be squares. Repeated. Oh, okay. So if it were repeated factors, let's think about this. What about when x equals -1? Let's test it again. So this, if you apply x to -1 to this equation, you get 1 plus 4 plus 7 -1 does not work anymore. -1 doesn't work. Now, so if it doesn't work, what about x equaling to 1? 1 minus 4 plus 7 minus 12 plus 12. That no longer works. Another hint is partial fractions with unfactorizable factors. So essentially we've broken down this to this form. That's what we have here. Let's bring this down. Let's bring this equation down somewhere. Okay, so we've got this equation here. How are we able to solve it? That's the question. It's not factorizable. So, is there even a way to solve it? Solve this partial fraction. Obviously, we know that there's going to be something like this. There is going to be a partial fraction, and yeah, do that. But now, let's think about the conditions when x is equal to 2. Think about it further. When x is equal to 2, you get 2 to the power 4 16 minus 32 plus 28 minus 24 plus 12, and you get minus 12, you get plus 16. Oh yeah, okay, so x is equal to 2 is a factor. So we can factor, use synthetic division again. So 2 is a factor. 1 minus 4 plus 7 minus 12 and 12. So that would be 2 minus 4, 3, 6 minus 6 minus 12, 0. So now we factorize the denominator to x plus 1 times x minus 2 times x cubed minus 2x squared plus 3x minus 6. This is the denominator right now, and let's think about, are we able to factorize the denominator even more? Well, let's try 2 again. No, let's just try 1. So that 1, oh, let's try factorizing this. X equals to 1, we have 1 minus 2 plus 3 minus 6. Definitely not. X equals minus 1 plus 2 minus 3 minus 6. No. X is equal to 2. So 8 minus 8, blah blah, 2, 6 minus 6, 0. So x, there's a repeated root of x equals 2. So let's apply synthetic division again to this problem. 2, 6, not. Okay. So the denominator can be further written as x plus 1 times x minus 2 squared times x squared plus 3. So this is the denominator we've been able to factorize to, and the integral here is thus x plus 1 to the power of a plus x minus 2 to the power of b plus x minus 2 squared to the power of c plus d over x squared plus 3 dx, and the numerator is equal to 3x to the power of 4 minus 7x squared plus 9x squared, 7x cubed plus 9x squared minus 8x plus 9, and that is equal to a times, let me think, so x minus 2 squared times x squared plus 3 plus b times x plus 1 times x minus 2 times x squared plus 3 plus c times x plus 1 times x squared plus 3 plus d times x plus 1 times x minus 2 squared. So now we let x is equal to 2, and we get that on the left hand side you have 3 times 2 to the power of 4, which is 16, and 3 times 16 is equal to 48 minus 8 times 7, 7 times 8, which is 56, plus 4 times 9, which is 36, minus 16 plus 9. So that's minus 20, plus 28, minus 16, that's going to be 12 plus 9, which is 21, is equal to, so you have c times 2 plus 1, so 3 times 2 to the power of 2 is 4, 4 plus 3 is 7, so 21, so therefore c is equal to 1. Then we let x is equal to minus 1, that x is equal to minus 1, we apply that to the formula above, so that's going to be 3 plus 7 plus 9, I think was 9, plus 8 plus 9. That's going to be 2 times 9 is 18. 18 plus 8 is 26. 26 plus 7 is 33. 33 is equal to, when x equals to minus 1, cross blah 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 out, so it's equal to a times, so minus 1 minus 2 is minus 3 squared, which is 9. 9 times 4, which is 36. I might have calculated the problem wrong. Oh no, this is 10. This is 18, 26. So this is 36. Sorry. So a is equal to 1. Then we have to figure out the rest on our own. So okay, so we have C and A. We just need to figure out what B and D are. B is obviously equal to 4, I think, because here, on the right hand side of the equation, the polynomial with the highest power is bx to the power 4, so b must be equal to 3. Oh, this is 3 actually. B is equal to 3. And C, don't know what C would be. Oh no, sorry. Wait, no. Wait, no, so no, so A plus B must be equal to 3. It's A plus B. A plus B is equal to 3, and we know A is 1, so B must be equal to 2. We don't know, what we don't know now is D. So, looking from the answer choices, so 9 is equal to, let's see, 4 times 3 was 12A. 12A, A is 1, so it's 12. Plus 2B. B is 2, so 2 times minus 2 times 3 minus 6. Plus C. C is 1, so 3 and plus, so 4D. So therefore, 6 is equal to 4D, so D is equal to 3 over 2. That's what we have. So now we can simplify the equation down, the integral down to this. So a over x plus 1, and a is 1, so 1 over x plus 1, b over x minus 2, b is what? B is 2, plus 2 over x minus 2, and plus c is what? C is 1 over x minus 2 squared, plus 1 over x minus 2 squared, and plus d is 3 over 2, so, and d is over x squared plus 3 over 2, plus 3 over 2x squared plus 3 dx. So that is what we have right now. And solving this indefinite integral, we get this would be ln x plus 1 plus 2 ln x minus 2. This 1 over x minus 2 squared would be minus x minus 2, I think. Let me think. Yeah. And the last one, it is plus 3 over 2 1 over x dx over x squared plus 3. How are we going to do that? Well, let's figure out the left hand side first. So together this would be x plus 1 so ln of x plus 1 times x minus 2 squared. I think minus 1 over x minus 2. Now we need to figure out how we can get the integral of x squared plus 3. And what you can do is say, for this solving this one, let u equal root 3x. And then, so du would be equal to root 3 dx. So therefore, the integral of dx of 1 over x squared plus 3 would be equal to the integral of 3 u squared oh wait a minute, no, this should be let root 3u equaling to x. So therefore du would be equal to dx over root 3. That's how you get it. Yeah, so now we have x squared plus 3 is equal to 3u squared plus 3. Du is root 3 here. Let's just say this dx root 3 du. So wait a minute, root 3 du. And so that's equal to this du over u squared plus 1. And so that's also equal to root 3 over 3 times the arctangent of u plus c. And we know that u is equal to x over root 3, so therefore the integral of dx over x squared plus 3 is equal to root 3 over 3 arctangent of u, which is x over root 3, plus c. If we substitute the values back to here, we have 3 over 2 multiplied by this expression. So if you multiply 3 over 2, you cross it out, so you actually get root 3 over 2 arctan of x over root 3 plus c, and the logarithmic value is x plus 1 times x minus 2 squared minus 1 over x minus 2 plus this. So this should hopefully be the answer to this incredibly complicated integral. This is an incredibly complicated integral to solve. Or was it x plus 2? Apparently, I probably made a mistake somewhere. Along the way that did not get the answer that we wanted. Let me have a think. This is evidently a very difficult integral problem, but I probably made a mistake somewhere along here. I think. I don't know. This is an incredibly complicated integral, so let's see the answer here actually. Oh. Okay, so apparently I got something wrong in the partial fractions here. B is not equal to -2. This is incorrect, by the way. It's partial fraction section that I got wrong, basically. So let's have a think about how to get B on its own. Okay, so A plus B. C. Okay, so we have to get B and D, solve those two numbers. We don't know them yet. And we can't assume that they are all kind of x-ish. I have to solve what B and D are, basically. B and D. And how are we going to go about that? Well, okay, so this is a partial fractions problem. This can be a pain. We know A and C are basically just one. Just need to figure out what B and D are. Now, I think we do have to expand the brackets in order to really find out what B and D both are in this case. Okay, so I'm gonna take a screenshot of this and paste it somewhere. So this is wrong. Let's come down here, insert image. Okay, so essentially this is the thing we have, the equation we have, and let's expand the right hand side out. So we get x squared minus 4x plus 4 times x squared plus 3. This expands out to be x to the power 4 plus 3x squared minus 4x cubed minus 12x plus 4x cubed plus 12, and this simplifies down to x to the power 4 minus 4x cubed minus 5, no, plus 7, that would be plus x squared minus 12x plus 12. So this is what's expanded. And part B, it's b times, we'll expand this out. So x plus 1 times x minus 2 times x squared plus 3. And that is equal to x squared minus x minus 2 times by x squared plus 3. And you get something similar to x to the power 4 plus 3x squared minus x to the power 3 minus 3x minus 2x squared minus 6, and you get x to the power 4 minus x cubed plus x squared minus 3x minus 6. Expanding on here, you get x plus 1 times x squared plus 3, x squared plus 3, is equal to x cubed plus 3x plus x squared plus 3. Reorganizing it, we get x cubed plus x squared plus 3x plus 3. And finally, for the fourth equation, x plus 1 times x minus 2 squared, so x plus 1 times x squared minus 4x plus 4. That's equal to x cubed minus 4x squared plus 4x plus x squared minus 4x plus 4. And this is equal to x cubed minus 3x squared plus 4. So we've got 4 answers here. We don't know B, we don't know D. So now, what we are going to say here is, in this case, we know something, right? In this case, for D, because x squared plus 3 cannot be factorized in any means, D, this should be dx. Should be dx here. So it's dx. So 4, 3x should be that. So now we have something. 3 is the coefficient of x to the power 4. So 3 must be equal to 1. 1 is here. B is there. So 1 plus b plus 0 x to the power 4 plus d. So we have 1 is equal to b plus d. Oh no, 0. It's actually plus 0 here. So 2 is equal to b plus d. And then we know that minus 6, we know that from the constant term, it's 9. So 9 must be equal to 12 minus 6b plus 3. So this is minus 3. This is 9. Nine equaling to 9b. B is 1. So we have A equals B equals C equals to 1, and D is equal to 1. So the integral is now 1 over x plus 1 plus 1 over x, let me see, x minus 2 plus 1 over x minus 2 squared plus x over x squared plus 3 dx. So tidying things up, we get ln of x plus 1 plus ln of x minus 2 plus, actually, minus 1 over x minus 2 plus, so 2x ln over x squared plus 3, that's going to be 2x, so divide by 2. Plus c, plus k here, plus k. So tidying things up, we have ln of x plus 1, x minus 2, times x squared plus 3. Minus 1 over x minus 2. Oh, okay. So half of that, so root, yeah. Okay. Because half of ln something means ln of square root of something. Okay. Plus c. I have to check the answers again. But this question is quite a difficult one. And I quite agree that it is extremely difficult. And we can simplify it a bit more to get this form, but it is quite difficult integral overall, and this is the answer. Let's go over what should have done. So first of all, I should have really expanded the denominator out and look at the partial fractions, solve it down to this, and really remember that if the denominator is indivisible in the partial fraction, the numerator would be x to the power of the highest degree in the denominator minus 1. And in this circumstance, we basically solved it. Yeah, pretty much solved it. It's quite a difficult question, but once you know the gist of it, you're able to solve it.